Hello students, the point of this video is to give you a quick rundown for how to manually calculate Pearson's correlation coefficient. So this is our formula for Pearson's correlation coefficient, also known as R. It tells me the strength of a relationship between two variables. So that could be X and Y, that could be height and shoe size, it could be education and income levels, it could be any two variables. So this formula is on your formula sheet and it's a bit of an ugly one. So what do all these little things mean? Well, N represents number of pieces in the data set, Xi represents a data point, X with the hat on it, or X bar, represents our average, Sx is the standard deviation of X, Yi is the Y data point, Y with the hat on it is the Y average, and Sy is the standard deviation of Y. So our final product will give us an answer anywhere from -1 to 1. 1 being a perfect positive linear relation, -1 being a perfect negative linear relationship. The closer to 0, the weaker the relation. So we'd have quite a strong correlation up here, but quite a weak correlation down here. Ditto here. Just because it's negative doesn't mean it's weak. We have a strong negative correlation here and a weak negative correlation here. Anyway, so the kind of question you might get would be something like this. We have a bunch of X values, a bunch of Y values, and we're asked to find Pearson's correlation coefficient, or R, and describe the strength of the association between these variables. So this question is nice enough to give us the average of X, the average of Y, the standard deviation of X, and the standard deviation of Y. But if the question didn't give me that, I could always determine that using my calculator. Anyway, so you'll need to set up a table something like this. You're going to need to do a lot of manual calculations to do this properly. So what goes in here is the first half of this bracket. So the first X data point is 2. The average of X is 5. And it's being divided by the standard deviation of X, which is 2.16. So 2 take 5 divided, so 2 take 5 divided by 1.6, oh sorry, 2.16, gives me an answer of -1.38, or let's make that -1.39. I do the same thing for Y. The first Y data point is 1.2. The Y average is 4.16, and the standard deviation of Y is 2.51. So in my calculator, I would type 1.2, take 4.16, divided by 2.51. And that gives me an answer of -1.17, which will round to -1.18. Yep, just checking I typed that all in correctly. What goes in here is the product of these two figures. So, what is the product of -1.39 and -1.18? Well, I would go answer multiplied by the answer from before, and the product of those two is 1.64, roughly. Then I need to do that for the next X and Y coordinate. So the next X coordinate is 3, take away 5 over 2.16. So in my calculator, 3 take 5 over 2.16, and I get an answer of -0.93. Yeah, pretty tedious, I know. I need to do that again for Y. So the next Y coordinate is 2.7. The Y average remains the same, 4.16. The standard deviation hasn't changed, 2.51. So I end up with 2.7, take 4.16 over 2.51, and I get an answer of -0.58. So what's the product of those two figures? Well, it'd be that figure multiplied by that figure, giving me an answer of 0.54, roughly. I am rounding most of these answers. Anyway, so look, as you can imagine, if I did every single one, it would be quite tedious, so I'm just going to let Excel do the remainder for me. So here's all my answers. You'll see it matches what I typed up earlier, and there we go. So these are all the X coordinate calculations, these are all the Y coordinate calculations, and here's all the product of those two. So looking back at the formula, it says here, I need to find the sum of all that. That's what this funky looking E is. It means sum. So the sum of all this, now I'm using Excel today, but you could of course use your calculator, adds up to 5.33. So I'm not finished because we can't have a correlation of 5.33. That's impossible. Now we need to look at the first part of the formula. 1 over n take 1 multiplied by the product of everything we just did. So what does that mean? Well, once I figure out what the sum is, I just figured out the sum of all of that information was 5.33. And let me clear this up a little. There we go. So how many data points were there? Now, you might say, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but that's not correct. There are only 6 data points, 6 pairs of data points. There's an x and y here, 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 and here. Did I say 6? I meant 7. Sorry. 1, 2, 3, 4, 5, 6, 7. So that means the n figure here is replaced with 7. So 7 take 1 is obviously 6. So we end up with a 6th multiplied by 5.33. So in my calculator, I would type that 1/6 multiplied by 5.33, and I get an answer of 0.883 recurring, which will round to 0.89. So this means I have a correlation coefficient of 0.89. 0.89 is the answer I've been striving for. So 0.89, that's a pretty strong positive linear association, which is probably what we'd expect looking at this data. It does seem to be going up with a pretty strong, the y values seem to be going up with a pretty strong connection to the x values. Oops, sorry, I'm going all over this. There we go. So an R value of 0.89. So in order to confirm the reasonableness I've got a couple of options. I can use Excel to help me with that. So I found it to be 0.89, but Excel also has a correlation feature. And let's see if I got it right. Yes, not surprisingly. Now clearly you can't use Excel in your exam, but you can use your calculator to help you. So if I were to enter those data points in a table here in my calculator, so these are these data points, x and y, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6, 7, 8, and the y value is here as well. So 1.2, 2.7, 2.3, and so on. So in my calculator, if I wanted to find out what Pearson's correlation coefficient was, I would go second, data, I would go to var stats, my x data is in list 1, my y data is in list 2, then I would hit calculate. So it spits out a lot of information, most of it we don't need right now, but if I keep scrolling down, I eventually do get the R value of 0.887. And what was our R value that we calculated manually? 0.89. So 0.887 would round to 0.89, so I can be confident in my answer there. Now, clearly, students, this is quite a long process, so I think it would be quite cruel to get a question where you have to do the whole thing in Excel. That's mean. But you may yet get a question that asks you to just fill out one of these values or just fill in one of these values, or they may give you everything. So they may give you all of this stuff and just ask you to do the last step. I can see them doing anything there. Anyway, I hope this video has been of some help, students, in learning how to calculate R, or Pearson's correlation.